So this question is 2015 Ijc P1 question 1. So a water tank is in the shape of vertical inverted cone with a height of 2 meters and a base radius of 0.5. So it's vertically inverted. Yeah, this one is like too mainstream on this kind of question where it's vertically inverted, because that I should have chosen more of when we're doing when you're nearing the prelims, we will do another type where it's like the other way around, the upright one. That one is more fun. This is like not so difficult. Water is flowing in the tank at a constant rate. So okay, you know that dV dt in is 0.01 meter cube per second. Okay, so coming out here will be dV dt out, because I read the question already. It says that it also leaves the water is leaking out, right, at a constant rate of 1.2 times 10 minus 4 meter cube per second. So find the rate of change of depth of water level in the tank at the instant when the depth of water is 0.5. Okay, so it was initially leaking out through a small hole at a constant rate. Okay, can. So the total dV dt net would be dV dt in minus dV dt out. Just a rate, 0.01 minus 0.2 times 10 to minus 4. Okay, this is given. This is the overall increase of water. Okay, because the going out is actually smaller than going in, so it will increase. Then what you want is actually the height is 2 and radius is okay lah. So this is height is 2, radius is 5. So the height is 2, radius is 0.5 meter. So in other words, you are looking at water, this water here. Here's water. Okay, water like that. Okay, great. Ayo. Okay, so this part here, the water would have a height also lah. So this height and this is changing. So maybe this height you put a capital H. And typically you put this as a capital R lah. It means it's usually the capital R and H, they are constants usually lah. So like R equals to 0.5, and then the small uncapitalized letters are actually the alphabets are actually the variables. Okay, so find a rate of change in the other H. So it's not too bad lah. So it's the same, exactly the same as the one above. So this is easier actually. So you also find dH dt. This is dH times dt. So what to put there? You already know what to put. So this is dV, dV, dV. Okay. Then you put this signify that you need to find volume in terms of H. V in terms of H. Okay, so there you go. Then, yeah, that's about it. What we're gonna do next is just expand. This part here is okay. So I'm gonna find V. The volume of water at the instant is 1/3 pi R square H. So R over H, R over 0.5 equals to H over 2. So R equals to 1/4 of H. So this will be 1/3 pi 1/4 H square H, which is 1/3 16 48 pi H cube. Okay, so dV dH will just be 3 over 48 1 over 16 pi H squared sub 1 into 2. This is quite manageable. This will be dH dt 1 over times dV dt, which is actually 0.01 minus 1.2 times 10 to the power minus 4, 9.88 times 10 to the power minus 3. Okay, so this case here we get pi h square to 9.88 times 10 to the minus 3. So when the depth of water is 0.5, when h equals to 0.5 meter. So the last thing you want to check is whether the units are all the same. So apparently all units are in meters, so you're safe lah. Usually sometimes you're gonna con if your units are not the same. So this part here is okay. This is 0.5 square over 16 times 9.88 times 10. So sometimes we can write like that. So the rate of change at time equals to h, right? So you could write this dHdt, h equals to 0.5, means at 0.5 this is the rate. Okay, that's the reason why we sub it at the end. So divided by pi divided 0.5 square times 16, which is actually 0.20127. Okay, 0.201. Okay, so this part is okay.